So this is going to be lesson 6 in our solving equations unit for variables on both sides, day 1. Your homework will be page 12 and 13. I have a warm-up up here. It's going to be 4 problems dealing with distribution and combining like terms like that we were working on last week. So if you want to hit pause and work on these. So looking at our first one, I have 2 times the quantity x minus 1 plus 4x equals 10. I want to distribute first. So if I want to take my 2, I'm going to distribute it inside. So I'll do 2 times x, which is 2x, 2 times negative 1, which is negative 2, and then I have 4x on this side, equals 10. Now, I can combine my like terms. I have a 2x and a 4x. So I'll have 6x minus 2 equals 10. I can add 2 on both sides, and I get 6x equals 12. Move that over here. To solve for x, now I can just divide by 6 on both sides, and I will get x equals 2. On this one down here, I have negative 5 times quantity x minus 5. Minus 5 again equals negative 20. I'm going to take my negative 5, distribute it inside. I'll have negative 5x. Then I do negative 5 times negative 5 again. When I have 2 negatives, it makes it positive. So I'll have plus 25 minus 5 equals negative 20. I can combine my like terms, which in this case is going to be my 25 and my negative 5. When I combine those, I'll have negative 5f plus 20 equals negative 20. I can minus 20 on both sides, and I'll have negative 5f equals negative 40. Negative 20 minus 20 is negative 40. Over here, I have negative 5f equals negative 40. Divide by negative 5 on both sides, and you'll get f equals positive 8. All right, now, this one over here. I have 3. Distribute that inside. I have 3y plus 6 minus 2 equals 25. I can combine these. I'll have 3y plus 4 equals 25. I can subtract 4 from both sides, and I will have 3y equals 21. I can divide by 3, and I will get y equals 7. For my last one, I'm going to erase some of this. For my last one, I have 2z plus 2 times the quantity z minus 6 equals 12. I'm going to take this 2, distribute that inside. I'm going to carry down my 2z right here. Plus 2 times z is going to give me 2z. 2 times negative 6 is going to give me negative 12 equals 12. I can combine my 2z and my other 2z to get 4z minus 12 equals 12. Add 12 to both sides. I'm left with 4z equals 24. Divide by 4 on both sides, and I will get z equals 6. All right, now moving on to our lesson. So I said we're going to be talking about variables on both sides. We're really comfortable with combining like terms and distributing and solving when we have one variable, even 2, if they're on the same side. But what happens when we put them on both? So when we're solving equations with variables on both sides, you want to make sure you're still distributing you're going to distribute, and you're going to make sure you're combining like terms. You want to move the variable to to one side of the equation. So you want them to end up on the same side of the equal sign. Then you want to move the constant to the other side, just like we do in a regular problem, how we just did in some of our other lessons. Then we want to undo our addition or subtraction and undo any multiplication or division, just like in the rest of our equations. So when we look down here at the first two examples, for example 1, I have 3b minus 4 equals b plus 2. So we want to look at the top, distribute and combine like terms. Well, we don't have to distribute or combine anything yet because there's nothing to do so. But we want to move the variable to one side of the equation. So I'm still going to split my equation. I want to get b on one side. So I'm actually going to subtract my b on this side, but I also have to subtract the b on this side. I have to do the same to both sides. So this will cancel out my b's on that side. Well, in this one, I have 3b minus b. So I'll be left with 2b minus 4 equals 2. And now it looks like the equations we've been working on, so we can just solve for b. I can add 4 to both sides, and I get 2b equals 6, divide by 2, and I'll get b equals 3. Now over here, I have 8 plus 4d equals 5d. I want to get the variables on the same side. For this one, I want to subtract my 4d. And I'll be left with 8 equals 5d minus 4d will just leave me with 1d. And I'm done. 8 equals d. Looking at our next two examples, I have 8k plus 2 equals negative 4k minus 10. I'm going to split it up. I'm actually going to add 4k to each side. So I'll get rid of that one. So on this side I have 8k plus 4k, which will give me 12k, plus my 2 equals negative 10 is what's left on that side. I can solve for k. Minus 2 both sides. 12k equals negative 12. Divide by 12, and I'll get k equals negative 1. Now, this one looks a little bit different. This is when we want to think back to that first step. We want to distribute and combine like terms first. So what I'm going to do, I'm going to take my 2, distribute it inside. I'll have 10x minus 2. And on this side, I'm going to do 3 times quantity x plus 11. So 3 times x will give me 3x. 3 times 11 will give me plus 33. And then I just have to solve for it. So we know to move the variables to one side. So I'm going to subtract 3 from each side. This will give me 7x minus 2 equals 33. I can add 2 on both sides. That'll give me 7x equals 35. And I can divide by 7 on both sides. So I get x equals 5. Now, if you are to flip to your next page, let's do example 8. Your science class is doing an experiment. You start with 2 plants. Plant A is 5 centimeters tall and plant B is 8 centimeters tall. Plant A is fertilized and grows 2 centimeters per day. Plant B is not fertilized and grows 1.5 centimeters per day. Predict in how many days will the plants be the same height. So we have to create an equation to represent what's going on in this problem. I'm going to give you a hint. Since we're talking about variables on both sides, in our equation, we're going to make one with variables on both sides. So we have to make or label a variable first. So in this case, I'm going to say, let D equal days, because we're talking about predicting how many days until the plant is the same height. So we want to set up our equation. So it says plant A, I'm going to write over here, plant A starts out at 5 centimeters. It starts out at 5 centimeters. And then it's going to grow 2 inches per day. So isn't that the same as saying 2 times D? And then our plant B tells us it's going to start at 8 centimeters. And that's going to grow 1.5 centimeters per day. So now we know what we're starting with, what they're going to grow by, okay? And we want to know when they're the same. This is not the same as when they're equal, so we want to set these equal to each other. Well, we're starting with plant A. It's starting at 5 centimeters, and it's going to grow 2 centimeters per day. So it's going up. We can add the 2 centimeters per day, right? And if we want them to be the same height, we're going to set them equal to each other. We're going to set them equal to each other, and it's going to be 8 plus 1.5 D. And now we can solve. We're going to move our variables to one side. I'm going to subtract 1.5 D from each side, which gives me 5 plus 0.5 D equals 8. I'm going to subtract 5 from both sides, which gives me 0.5 D equals 3. And over here, I can do 0.5 D equals 3. I'm going to divide by 0.5 on each side, and I'm left with D equals 6. And we said D is going to equal days. So now we know it's going to take 6 days until plant A and B are the same